Uh,
This conference will now be recorded.
okay. So should we go to the platforms of trust?
Yeah, go for it.
Okay. Just a reminder, the link is down at the bottom out here. And I was actually, Nate, one question to you. I was wondering if you could start a drawing document and add a link to this as well. Because I wanted to add some drawings and I wanted to kind of do the drawings in Google Docs so we can then easily, collectively edit them if we wanted to. And I tried to do it myself, but turns out that I cannot really share I cannot invite anyone to my document outside of Intel. So if I did that, it would be kind of pointless for everyone else. Um,
All right, I'll start one now.
okay, cool, thanks.
I don't see a
So
link. Like, did you paste a link into the chat window or?
No. So the link is out here, but I can copy the link
Okay,
into the chat window as well.
Okay, I see it now. Okay, I was looking in the chat window.
Sure. Yeah. No worries. So I started a draft for a platform of trust. I didn't get as much done as I wanted to, but I kind of at least put an outline that I have in mind, and maybe we can talk about that. I copied some of it from the other drafts that we used, so this is pretty standard. Kind of the main introduction that I start with is the NIST publication, which outlines the kind of the three main principles, which is the protection, detection, and recovery. And this is kind of how I want to build the rest of the document around it and around the three types of root of trust that this document creates, which is the root of trust for updates, root of trust for detection, and root of trust for recovery, and kind of how that plays with the platform root of trust, and as well as later some hierarchical root of trust approach, where how do we actually communicate with the symbiotic roots of trust that are maybe on the platform. So that's kind of the intro that I'm going for here. And then there is this, I guess, there's this Cloud Security Industry Summit meeting, which is run by Intel, but essentially it invites the key cloud players, and it had a open paper about the NIST spec. And in that paper, the CSIS outlines kind of three gaps that they see in the NIST spec that the CSIS kind of sees as critical for the cloud infrastructure. And the first one was the how to ensure the trace instruction integrity, how to create the chain of trust for peripherals. So again, talking to the platform active root of trust, talking with the components root of trust to establish a chain there, and how to create a automatable recovery scheme. So I added those three gaps that the CSIS paper pointed to, and the link to the CSIS paper is here. Although it is, I believe you need to kind of register to get to it, but you can find the link out here. So I also kind of later I kind of want to tie into that as well a little bit, so that we can essentially maybe address some of these issues here, and then CSIS can link to the OCP document. And there are actually today there's a CSIS meeting, so I don't think that anyone from CSIS is dialed in, but over the last couple of weeks, some people from that are part of the CSIS were dialing in. So that's Yigal from Microsoft, Ben from Google, primarily. They are the most active in the CSIS on the CSIS side. But right now, I think they're going to have a face-to-face meeting in a moment in Seattle. So
on the one question on the first instruction integrity item. So as far as in a way it's verifiable by the cloud provider, I mean, are they talking about attestation there or something else, or do you know what specifically that means about
So
the
this is
verifiable?
sure. So this is primarily kind of like a in case, for example, that you cannot sign that the cloud provider is the end user, and maybe we should change this to like the platform owner. Make a comment here so that we can do this later. But this primarily touches on the case where you as the platform owner, if you're not able to build and sign all of the platform firmware that you're running, at least give the platform owner ability to co-sign the firmware, so that you as the platform owner control what's actually running on the platform, and then attestation ties into that as well, so that you can verify that. But the first step is essentially to give some options that you can enforce what is the firmware that is executing on your platform. So let's say, for example, now in the platform active root of trust, where like in the Cerberus or Titan view, where they control what's on the SPI flash, right? That the CPU and BMC will fetch. Bunch of that firmware that's already in there is already signed by the silicon manufacturer, for example. But because of through the use of the firmware manifest that Cerberus, for example, outlined, you kind of enforce this co-signing, right? Where you essentially can control what's on the flash, and therefore you control what's being fetched. Although ideally you would also kind of do the enforcement on the silicon itself when it is starting to actually fetch the code and execute the code, so that you avoid any type of problems with time of check, time of use scenarios.
Okay, thanks.
And you'll see that we're already halfway there, and so this may run a little shorter than a whole hour, but kind of where I start with on the architecture side is, how do you actually establish the root of trust, and this essentially ties into the secure boot. That kind of repeat how we need to do a secure boot from an immutable root of trust using key material that we store in some one-time programmable space in order to verify the later mutable code. And one part here is that I want to ensure that we do both verification as well as measurement of both the authentication key and the firmware, so that later we can attest to both the key that was used during the verification as well as the actual code that has been verified. And I pretty much want to link to the secure boot document, and I will pull in a couple diagrams from there. This was the example that Brian had in the secure boot document, and I actually want to redraw this in the Google Docs so that we can later tweak it. This diagram is shown as a guideline, not necessarily a strict format how to do it, but more if you want to do it properly and you don't have idea why, use this as a guideline essentially to get things going. And I also want to add here some flow diagrams for the secure boots on top of just the how it essentially does this look on the kind of on the binary side on the firmware in the memory. And outside of that, I really mostly have kind of more of an outline than filling. So I'm also going to have a part of how do we do this. Also, how do we create a platform active root of trust out of a FPGA or CPLD class of devices, since that's something that I'm actively doing on the Intel side. The other pieces is how do we do attestation of the root of trust, and here Elaine is doing a really good job on the attestation spec. So I'm primarily just going to reference the attestation spec and see if we want to add any specific details about the platform active root of trust. But no, this is really the most mature document that we have right now on the attestation side. So that's going to be this part, and all of this is of course very much work in progress. As you can see, I pretty much just have what I want to add there, not really any content yet. One thing that I want to touch is as the platform of trust agent sitting on the traditional server platform, there's a bunch of legacy devices out here that will continue to be there for foreseeable future. And I want to kind of outline what are the various assets that we need to pay a little bit of special attention to when it comes to protection and ensuring that the platform, the PA-ROT essentially protects to make sure that we don't compromise the server platform. So this will primarily touch on the NOR flash memories like SPI flash, some power delivery components that exist on the platform, power supplies, digital VRs, stuff like that, and what the platform of trust should do to protect those components against tampering, and also how to properly do a secure configuration update and stuff like that. The next part is going to be essentially how to establish a chain of trust between the main platform active root of trust and the symbiotic roots of trust on the platform, like other silicon components, CPU management controller, as well as PCIe devices. And the NIST spec did a pretty good job here, so I'm going to mostly leverage that piece and also pull some stuff from the Cerberus docs that are on GitHub to outline these pieces. Now this section, I kind of want us as a group to align on a minimal required use for X509 that would allow us to essentially limit the amount of firmware that we need to build in our root of trust devices to support X509 certificate. Because if we want to do the whole X509 world, that's a lot of kilobytes of firmware that I don't think we really need. So I kind of would like to settle on one required format that everyone has to support and the required features that hopefully we can all agree on, so that we can essentially limit the amount of firmware that we have to write to handle the X509 certificates. Since I think we all want to have a small TCB as we can for the roots of trust.
One question on that one. Have you heard about in smart cards the card verifiable certificates? It's an ISO standard that smart cards, can't have an X509 parser in themselves, right?
Yeah.
And so this group in ISO, a European group, had established a standard for certificates that smart cards could verify. We might consider it. That's a possibility. It's a lot easier to verify.
That's a good point. Although one of the problem is that since a bunch of the stuff that we're doing with leveraging from USB sites, that we're doing in PCIe and DMTF, is assuming X509. So I don't know if we're going to be able to actually get out of X509.
Yeah, I would strongly encourage everybody to look at alternatives to X509. That's a lot of string parsing, and the string parsing inevitably leads to like some kind of buffer overflow, underflow type of attacks, and you don't want your some device to be able to compromise your root of trust because you're using X509 certs. I don't know what other standards there are, but the more minimal the definition for the certificate can be, I think the better it is.
And one of the
Yeah.
things, one of my colleagues is on one of the TPM committees. He's editor of the, I don't know, one of the standards, Ken Goldman. And he was saying that an item under consideration is to have the TPM actually sign, to be able to generate and sign X509 certificates. And there's a lot of controversy, but that's in the works. That would be an interesting development if it happens.
Is there any proposed drafts for that, or is it just some kind of a thread in the work group?
I think it's a thread in the work group. I can ask him if there's anything that exists.
Yeah, no, I started kind of to look internally also what different certs we're using. So I haven't completed that task internally, but I don't know. Hopefully, my goal is that if we have to do X509, and at least right now I think it looks like we're going that way, then at least know if we can all align on the format and the minimum set of fields that we need to support. Then I think we could kind of create a minimal library to support that, and that's hopefully would help with some of the issues that Sahil pointed to. That if we have 80 kilobytes of firmware just to parse certificates, there's a lot of potential for bugs in there. So
yeah, a lot of history of bugs too. It's not an unfounded concern.
On the
Absolutely.
platform,
Maybe there's an option we can bring in. So Wojtek and I have been looking at this as well, and maybe we could bring in a constrained X509 cert that we're thinking about, and kind of show what fields we were thinking, because that's totally agree on this front, right? It's something that is frequently exploited, but at the same time, going after some other different format might put us in the wrong spot as well. So it seems like what we should do is just align on what format we do want to support, what fields we want to support, and constrain that as much as possible. Make that parser really, really simple.
Yeah, that would be my hope as well.
So on the platform chain of trust, which obviously we need to get filled out, but is there an assumption that the main platform root of trust, has the ability to control either like powering up these other devices or bringing them out of reset? Or before it authenticates and does an attestation with them, say, okay, you are who you say you are, and if say that they aren't who they say they are, then does it have to have the ability to kind of like power them down, or is there some hardware assumptions about the ability the platform root of trust has with respect to these other devices, and what it either is turning them on or turning them off, or I'm just curious about any assumptions or thoughts about that.
Sure. So ultimately, no, that would be. I think there should be a way for the platform active root of trust to definitely do attestation of those devices, and then on the enforcement side, no, there is a question, right? Do we want to add direct control over those, or do we just want to have a way that we can convey a message to the rest of the platform that talks to those devices, that those devices are not trusted, right? So, for example, if we're talking about a PCI device, can we essentially communicate to the firmware on this running on the CPU side to essentially say that, hey, this device is not really trusted, protect yourself against it with like IOM URLs or something like that, right? So that you don't the device cannot DMA any malicious stuff into the host or extract any stuff from the host.
I think you probably want a model where you shut off the device at the first point it tries to get onto a data bus, and not at the point where it tries to protect itself from where the CPU tries to protect itself from the device, because otherwise you run the risk that the device can initiate some sort of peer-to-peer transaction and try to compromise another device, which is allowed by the IOMMU to access main memory.
Sure. And I'm okay with that as well. It's just like whether other people are okay with the platform attribute of trust to have a control over power for the other on the system.
Wojtek, I think
in the case of Titan, and I think Cerberus is the same, it doesn't control power, but it does control resets to devices and verifies the device's firmware before it's allowed out a reset. So you know in advance if you're booting with untrusted firmware. And I know in the case of Titan, we tend to let things boot anyway, but withhold security keys from the device. So, because we want everything to boot so that we can potentially diagnose remotely. We just don't give it access to like its hard drives or flash drives or anything else that might be in the system.
Sorry, Nate, you don't give the device access, or you don't give the host access?
The host, sorry.
Okay.
Well, I guess, Nate, are you talking about a case where the host processor kind of failed a security check, or just like where some PCI device failed a security check?
Well, I'm thinking specifically of, yeah, I mean, either. I mean, once you have one device on the system that's sort of known bad, you kind of have to assume the whole system is now sort of infected or malicious.
Okay, I see.
But we don't want to power anything down or brick anything, because that completely kills your ability to diagnose anything remotely.
Yeah, but for example, in Sahil's point, no, I guess Sahil would like to isolate the device, right? Which means that like you would prefer to keep the device in reset, for example, right?
I think there's a concern of lateral movement, but I think it's ideal versus practical. I think the ideal world you'd like to do that, but realistically, for large scale deployments, probably just controlling it at a higher layer by not providing keys if the server fails attestation is probably more scalable.
Yeah.
So I think it's one of those things that's optional, and I think a lot of people will just be like, let it fail open and we'll go diagnose what happened. Because it could be something, most likely it's going to be something non-malicious, bad flash, or bit errors or something silly like that, or somebody made a mistake flashing the firmware.
Sure. And I think in reality, I believe that we should also start demanding from the CPU firmware that it should protect itself as well. As we see more devices with these capabilities, the CPU should authenticate devices as well before giving the device full control to full access to the system.
Yeah, I mean, I think I would prefer if we didn't put this burden on the CPU to the extent possible, and I think that's basically philosophical difference in alignment. But like saying that you're going to use the IOMMU and things like that, it depends on how easy it is to configure the IOMMU, how the device has access to different portions of memory, whether you can isolate one device from the other devices in terms of memory, things like that. So sometimes it might just be more might be simpler to just disable the device at the PCIe switch level, right? The lowest level switch or something, if you can trust that.
Okay.
So yeah, I don't think I think it's very much going to be like, yeah, these are your options. You can implement it whichever way you want, but I would like us to steer away from baking in assumptions about what the CPU can and cannot do, because it's also going to have to work for, think of like a BMC module or something, right? We might want that to be its own standalone platform module and have its own standalone platform root of trust, and it may not be capable the CPU on there may not be capable of having an IOMMU or things like that.
Sure. Okay, that sounds reasonable.
And then I guess with regards to the host CPU, I mean, I think, isn't there an assumption that this platform root of trust is like coming up first prior to the host CPU? And I don't know if it's like assume that it's going to release the host CPU from reset and then be able to kind of convey, you know, some, I guess, attestation information about what it found. Is that true? Like that the host CPU is not like booting at the same time as this platform root of trust, I assume, right?
Yeah, and in my mind, the host CPU will just be another ACU root of trust as well. It's just that being more complex, it may fetch additional information from the platform active root of trust about the state of the platform. Kind of similarly, like for example, the management controller, can fetch this information for attestation of the platform. The CPU could fetch that information as well for some policy actions that it needs to take, right, as an active root of trust.
Is that interface something that's going to have to get standardized? Like, you know, if there is the ability, say, to have a host CPU fetch information from this platform root of trust, you know, does that need to be, is there a goal to standardize that, or the way that happens so that you could have two different implementers? The host CPU could be implemented by someone and this platform root of trust by someone else, and they can actually talk to each other to extract that.
So I would ideally like to piggyback on some of the work and some of the proposals that we had done for MCTP communication. So in general, I would envision that the PA-ROT will talk to the various different roots of trust on the device over SM bus, MCTP. Actually, MCTP is maybe better because then it is not prescribed what's the actual physical link layer, right? But essentially, we can use MCP to communicate between the various endpoints and use some of the work that was proposed by both Cerberus and in our PCIe spec to do at least the authentication and attestation of the root of trust over MCTP, and then add on to that some essentially a secure channel over which we can exchange communication. So hopefully that's we're going to get into, like, I would like it to get to a way where it's going to be standardized and we could have full interoperability between let's say a device with a Titan or a Cerberus talking to a Titan, Cerberus, or something else on the platform, let's say, right? As long as everyone is talking the same language, they should be able to do the basic stuff together, right?
I think a picture of that would be helpful. I mean, I that all makes sense, and I think as far as trying to like just communicate the overall view of it, I think that kind of shows where some of these protocols are involved. I think just some kind of hypothetical scenario, I think would help just kind of communicate that picture. But
yeah, absolutely. And actually, my kind of last part is about this communication in the platform chain of trust, and that's kind of where in the hierarchical trust operation section, I want to outline the use of MCTP for this communication. So kind of this next section that I will write up is kind of the main, kind of coming back to this main root of trust for detection, update, and recovery, and what are the key actions that the platform root of trust takes in order to essentially satisfy those for the base platform components. So before we even go to the chain of trust and symbiotic devices, essentially what do we do on the platform itself to be able to detect a corrupted or malicious firmware? How do we go through secure update process? And I believe we also have I think secure update spec somewhere. and the basis of recovery. And you can kind of look at that. That once this is outlined, then essentially, if from a device point of view, the root of trust on the device essentially does the same things to the device itself, and then it communicates through the chain of trust with the platform active root of trust to either for help or for attestation, essentially. But those are kind of the three main items that help us satisfy the essentially the main core functionality of the root of trust. And as the last, go ahead.
Yeah, I have a question regarding what you said before regarding using MCTP. Are you going to clearly state that MCTP shall assume FCTP over SMBus and not any other medium? Because, for example, using MCTP over PCIe kind of contradicts a base requirement that a device shall not be able to communicate on system bus prior to being fully authenticated.
Sure. No, so definitely in this case, right? So let me add some more things here. This will definitely be a out of band path for communication.
Yeah, exactly.
Right. So definitely the MCP here, in a sense that it's happening out of band, not over the main interface of the device.
Yes, but you have also MCTP. Yes, but MCTP is available both today, both over SMBus and over PCIe VDMs, and it needs to be ruled out the usage of MCTP over PCIe VDMs prior to the conclusion of the authentication. Yes,
absolutely. In this sense, I think primarily of MCP over SMBus. But okay. For example, you could do MCP over other buses other than just PCIe or SMBus. So as long as there is an out of band.
Not really. The two other alternatives, USB and UART, are only designated for MCTP host interface and not for MCTP management protocols.
Okay, yeah. So definitely, in my mind, this is MCTP over SMBus.
So okay. I think Yuval's question kind of brings up sort of highlights this issue that I think that at least I'm starting to see, which is that we need to be able to now tell device vendors what is expected from the device on the hardware side, right? Does every device need to have an I2C interface? If they need to have a platform, be able to support device attestation? Does every device need a securely generated device unique key? So I feel like there's now, for the next generation of devices, there's, vendors are asking questions and we don't have anything to point them to. And I know that we're kind of a volunteer army and we're doing as much as we can, but I'm wondering whether we can take the hardware parts of the requirements and nail those down, because that's like, I don't know, a 2-year window of time before those actually get baked in. I don't know about what Nate is telling his vendors, but we're certainly trying to provide some kind of guidance to vendors. We don't want to wait another year to be able to tell them what we need.
Yeah, no, so kind of, I guess it depends. Do we want to go as deeply in the hardware details, right? I think that if you read all of these documents that we have so far, it kind of leads to the way where, yes, you do need to have secure storage for keys. You do need to have unique identity. And at least out here, we will see that, yes, you do need a SMBus for this out-of-band communication. Now, do we want to have a document that just outlines the hardware specs? That would be useful, right? If you're talking to customers, that you can point them to that,
Right.
and then to the other documents that say, now what do you do with this hardware, right?
Right.
So-
Because I mean, the firmware, the attestation protocol, all of that stuff, you know, they can implement that in firmware, so there's plenty of time for them to do that. But the hardware stuff they need to bake in early. So yeah, I think it would be useful, and I can take that as an exercise to try to like summarize the hardware requirements somewhere, and then if we collectively agree that it may be that there are gaps that we haven't discussed, but it's also possible that more or less we know what we want from the devices, and if that's the case, then at least we have that we can point them to.
Sure. On the hardware side, I would imagine that we would also then need to specify the minimal crypto strength as well.
Yeah, we would need to specify that. We would need to specify if there need to be certain protected regions, whether things need to be in mass CROM or OTPs, or keys need to be generated on the device or externally provisioned, all those kind of things. Yeah.
Yep.
To some extent, it influences what kind of IP selection they do.
Sure.
And is the hardware connection between the host and the platform root of trust, is it also MCTP over SM bus, or is that?
I think that's a good option too, because now in many cases CPUs already know how to talk MCTP, and they have SM bus agent that they can do this. So I would imagine that we could leverage the same for the CPU to the active root of trust, to the platform active root of trust.
Okay.
Elaine, I think you had a question.
Yeah, one thing that I got into in my last draft was trying to identify the musts and shoulds, so that we can nail down at least those requirements, and those musts will then lead into the hardware document, I think.
Mm-hmm.
So as we're writing these different bits and pieces of the documents, any chance we have to identify those is a good thing. I mean, it may just lead to arguments and discussion, but at least we can figure out where we're going. Just as an example, if we ended up settling on X509s, we'd have to say, a platform root of trust must support parsing of an X509 DER encoded certificate, or something like that.
Mm-hmm.
So, just as you draft, that's for anybody who's editing. Try to identify those if you can.
Yep.
I believe that we need also a section in the document, unless it's already mentioned, about the relationship between doing firmware update or resetting the platform root of trust and the system behavior in that case.
Yeah, let me.
Yeah, I scratch my head on that one, because it seems like those reactions, I guess, or responses can be so policy driven, right? What we do.
Not really. There are some kind of hidden assumptions behind the scenes about the sequence of events on a given platform, like devices are not allowed to engage into the system prior to being fully authenticated.
Right.
You're resetting the platform root of trust. It has no knowledge, and it cannot have knowledge about prior operation because it performs its own secure boot on its own, right?
Mm-hmm.
So because of attestation requirements and all that stuff, We need to at least have some wording to cover that either the system has whatever defined in that particular system to allow continuous operation in that event and what it means in terms of system level requirements, or that this operation should only be allowed upon full system level reset or whatever. But we can't ignore it.
Yeah, I wonder, is that then and something that's out of scope, because then it's an attestation from the platform that says this is what I do in my case when I
No,
have.
because each and every device does key exchange with platform root of trust, right?
Mhm.
The whole session got lost when you reset the platform root of trust. What happens on those devices? What's expected from their behavior when they fail to communicate with the platform root of trust? How do they know that they have to reinitiate the whole key establishment with it?
Oh, I see where you're going. Okay, so when the platform resets, you want to instruct.
Platform root of trust element resets. What's the
Yes,
relationship between that element and the whole of the system? Yeah.
and the devices.
Yeah, the simplest view would be that no, that the platform resets along with it, but it may be more
Fully legit and the
destructive,
easiest
but
approach. Yeah, but very painful.
very painful. Yes. So yeah, if we can have a provision that the platform can continue operation while the platform active root of trust resets, and then just reestablishes the connection, that would be less painful for the operations, right?
Mm-hmm.
That's a good point.
But then in that case, if your platform had measured all of its children devices, that's all lost, then where's the history, right?
Exactly.
I guess Yuval, you said that the scenario is like as a firmware update to the platform root of trust. Is that what scenario?
Exactly. Because if you have a method to down communicate with the platform root of trust from whatever higher level, an indication saying, don't worry, everything is cool, that's a classic backdoor, and we won't go on that path. So we need to see how we treat the scenario of updating the platform root of trust firmware, or even just resetting it by watchdog reasons or whatever, which may also happen.
Is this as simple as saying that if the platform root of trust is reset, it's going to reattest the devices, and if it's not being reset as part of, it needs to know somehow that whether it's a full, hard reset or a soft reset. If the whole system is being powered on, then it can assume that the devices are not running. But if the whole system is not being powered on, then it should just reattest without trying to prevent the devices from accessing system buses.
Maybe, but we need to see how it fits with other stuff that we discussed, like Cerberus, which requires some of the platforms to have key derivation sequence and be able to use those keys to communicate, and then losing those keys. So at this point in time, they don't have in their position even the ability to use all these already lost keys. So we need to see what it means.
Yeah, I feel like from security point of view, it would be easiest and safest if we just assume that, for example, if we do update of the platform of trust, then that update can only happen during a full reset sequence of the platform, right? But no.
Yeah, I think
that's a challenge.
I think it's fair for that, but you can also imagine a situation where, let's say, your platform root of trust is not, a Cerberus or a Titan, but a BMC, right? And I can totally imagine somebody saying, I want to reset the BMC for whatever reason.
Yeah, and without really impacting the rest of the workload that is operating, right?
Yeah, Yeah. So I think it's, still good to sort of think through this scenario. I think it's okay to say for things, yeah, for if your platform root of trust is a Cerberus chip, it's okay to say that the firmware update can only be applied on a full system reset. But if your platform root of trust is a BMC, there's no reason you shouldn't be able to apply the firmware update and reboot it.
And also, what about other devices? If say you update the firmware on a PCIe device, and I guess presumably itself needs to be reset to have that take effect. Can that happen on a live system, or is that also part of an overall system reset, or can you actually have some of these devices, resetting and then, I guess having the same, maybe authentication and re-authentication and stuff. I don't know if that's a scenario is what the requirement is.
We could force in every reset, we could force re-authentication, right? We can mandate that.
I guess you may not. I guess if your only way of communication between the active platform active root of trust and the symbiotic root of trust is then MCTP over SM bus, then you may not actually be aware of either reset of the device or hot plug of the device. So really, the only entity that is aware of those events is the host CPU, which is why I wonder if in those cases we shouldn't just seed that activity on the root of trust inside the CPU to enforce this authentication during that stage, because we have established a chain of trust to a symbiotic device, and that device could then be responsible for re-authentication of devices that are kind of further along the chain that it sees.
Sorry, I'm not following what you're saying, Wojtek. Are you suggesting that some device that's closer to the device being reset is then responsible for doing the reattestation?
Yes, something like this, where this is a CPU and this is a PCIe device, right?
Mm-hmm.
If this PCIe device resets, or if there's a hot plug of this device, the PAROT doesn't really have a way to learn about that by itself. But the CPU in this case does, because it gets all of the alerts, it gets the information that there's a new device in the link or the device reset. And since we have established this chain, I think it would be imaginable that this AC root of trust component essentially attests this device and then communicate back that, hey, I saw this new device, and this new device is this information, and then feed back that information back in there.
Or communicate backward, yeah.
Yeah, or the CPU.
Or communicate that there's a new device.
Yeah, it tells the PA root of trust to reinitiate attestation for some device.
Yeah, I would go on that path, and you'll have one flow for testing that device.
I guess, Nate, can you say anything about Titan? Like, does it support hot plug? If a PCI device is hot plugged, how does Titan become aware of it, or is that even a scenario you care about?
That's not a scenario we care about.
And what about live firmware update?
To me or to Nate?
Nate.
Oh, sorry, what was the second question?
What about live firmware update without platform level reset to a device in a system?
So for devices in the system, we do support like live updates. But for the platform root of trust itself, it does require a system reset because we only allow updates at a specific time early during boot.
No, I'm not talking about the platform root of trust. I'm talking whatever device in the system which is being measured by Titan. Can Titan remeasure that device once it's resets and do the whole reestablishment of trust between that device and the system?
So Titan is basically only responsible for its specific device that it's protecting. So the Titan itself doesn't really have a concept of other Titans in the system.
Yes, but let's say a given Titan isolates a given flash of a given device and allow access to the device towards that specific flash device only after it's done measuring that flash content and whatever. Then you're doing firmware update and you want to reset that device. Is Titan aware about the device going through reset or not?
Yes. So whenever the device gets reset, Titan will re-verify the firmware contents before letting it out of reset again.
Okay, so but that's a device level Titan. So is there a central Titan that's kind of tracking all this, or is it just each device kind of has its own Titan protecting it?
Right now, each device has its own.
Okay. So there's
So
not
you
a centralized platform level Titan that kind of coordinates all the others or something. Yeah.
There's not at the moment. We're actually looking at a lot of working with OpenBMC to sort of use the BMC for that kind because it's significantly more capable than a Titan chip.
Now, I don't know if you want to share that with us, but if a device initiates kind of software controlled reset with no visibility on the IOs of that device, how can Titan know that it needs to remeasure?
In that case, it can't, but if the device attempts to request any, so resetting the device will clear any security keys that device has, and it'll have to request new ones from the Titan. And Titan will not give it new keys unless it knows that it reset and can verify its flash contents again.
Got it. Okay, thanks.
One thing that Nate's describing is essentially that the Titan is trusted, right? The peripheral Titan is trusted to do the right thing, which is, it says, well, I'm going to hold you in reset, or I'm going to make you reattest, or whatever it is. It's to remeasure. So why are we not using that same model on our devices? It says, okay, maybe there's 100 vendors out there, only 3 of them do the right thing, and we want the others to start doing the right thing. By having the device ID and the vendor and so forth, we can decide whether it's one that complies or not. But without doing it dynamically, it's determined whether this device is compliant to the spec. Just like the Titan chip, it's a Titan chip, therefore you trust it.
Sorry, are you saying that you would trust the device based on device ID and vendor ID?
That's one question. Yes. So if you were going to do that for device reset, how do you know whether the device is lying to you or not? You won't, right?
Yeah, I think it sort of it depends on your threat model. I think if you're just trying to say that you have secure boot firmware and you trust the device to report the right device ID and vendor ID, that's okay. But if you assume counterfeit devices, again, it depends on depends on how the device ID and vendor ID is being reported back. Is it through firmware? Is it through PCI config space, and firmware cannot interfere with that? But I think that in general, it's a better idea to have some kind of attestation of the device.
Yeah, because
Yeah,
if we
and
include
let this,
standard devices, then that data is very easily spoofable, right? And it's very easy to be replayed without attestation.
yeah, like what I could attest everything and make you happy, but if my device is poorly implemented and it doesn't do the right thing, how would you know? I mean, how would you know that whether I did a reset and changed all my measurements? If you can't find out, how do you know?
Are you saying that? I mean, I'm not sure I'm following, but are you saying that there's a device that is poorly implemented by the vendor?
Mm-hmm.
Yeah, I think
Yeah.
the only solution to that is, you need to have some kind of trust in the vendor, or you need to have some kind of requirements, or you have independent third parties verify their implementation. That's applicable to their, root of trust, their mask ROM, everything.
Yeah, you were on the same page. That's exactly what I was trying to say. You
Yeah.
just said it better.
I would like for us to come up with some standard eventually that's like a third party validation kind of thing, where you can say you need to meet these requirements, and somebody can go in and do an audit and say, yes, this device is being manufactured properly, or it's not. And that would be a good thing
Yeah,
to have.
this is Aria Seagate. I've been sitting here like a church mouse, but I am on the device side, and this is a much longer conversation. With storage devices, there's a lot we do and a lot of audits we go through with the government. There's basically an end-to-end security model from design in. There's a secure boot that's really a device secure boot within the device itself. We use PKI. So at least for storage devices, and I think I don't just speak for Seagate here, there are a ton of requirements. I can't speak for all devices.
Yeah, I think I would agree with that. By the way, this is Adrian, and reduced storage too. So at Intel, and you're right. There are a lot of them, but I think Sahil's point is that maybe there may be a certification and those kind of government certifications that are there.
Yeah, I mean, certainly if it's a FIP certification, I don't think people put a lot of stock in those. So I don't know if there's government certification that's accessible to the rest of us. If it is, then it would be a good thing to piggyback off of.
Just to avoid the political debate on that one, I mean, there are a lot of people that do put stock into the certifications, but I'm just saying for this particular usage model, there may not be something that's readily applicable right now. And that's where, other than there's another certification out there, the Common Criteria Protection Profile stuff, but it's not directly applicable to this. So I think that this forum will have some work to do to put together something like that, right? So this is, obviously this is what we've been working on for months, right? These are the requirements that we're all going after, but now we need to say, okay, this should be tested this way as part of an actual certification process. That's what it seems like is needed here.
Yeah, I think compliance testing can be an entire separate project on its own. It's a pretty large, difficult problem to tackle.
Yeah, at least today, if you need to go through FIPS certification as an example, you need to recertify each and every firmware release, which implies, not only the consequences of cost for each and every release, but also the scheduling impact of fixes and release dates and all that. It's not so trivial to require that.
It's not, but there is an NIST audits that we go through that are a much lower barrier. But you're right, FIPS is plus. Yep.
Yeah, the agility and the review process is indirect opposites, right, of the spectrum.
Yeah, and we went down this rabbit hole from reset, right? So if you have a device that resets and doesn't tell anybody, how do you know, right? It resets and you have no way of knowing. You have no way of knowing, right? That's it.
Yeah.
I need to run. But I will work on some of those those parts this week and next week as well. So we will probably see some edits coming in the document.
Thanks,
All right.
Richard.
So I guess before we head out, the next two meetings are next week is Brian for Secure Boot, and then Lane with more attestation, and then the fifth is Prabhu with another Spiral protocol review. And then we are open after that. So if we want to come back to the platform root of trust, we can start after the 5th.
Sure. Sounds good.
Thanks, Nate.
Bye.
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 Everyone.